7.2b. All right, we're going to continue U-substitution, but we're going to do U-substitution with a definite integral. Definite integral. Okay? So in other words, it's going to have an a to b, like interval. Yesterday, those were indefinite. Today, they're definite. Integral. All right. So it's pretty cool, these definite integrals. You do not need to resubstitute at the end. You know how when you're done, your answer's in u? You don't need to substitute it back to x. I'll show you a way to do that, okay? All right, 2 examples. Here we go. Number 1. All right, we're going to evaluate by hand, okay? It's important that you know that. I won't give you any credit if you just give me the answer, because I know our calculators can do a lot of this stuff. We're going to evaluate by hand the integral from 0 to pi over 3 of tan x times secant squared x dx. And then hopefully they'll tell you what u is. Say let u equal tan x. Okay. This part, this substitution part isn't new. This you should be pretty good at, you know. We did a lot of this yesterday, so here we go. Let's do it. So it's the integral from 0 to pi over 3. I'm going to leave that for a minute. Just write that down. And then we're going to substitute in. So we have u times secant squared x dx. All right, so here we go. We're going to take the derivative of u. Du equals, and what's the derivative of tangent? Secant squared, yeah, there it is. Du dx equals secant squared x. And so that means that when you solve for dx, you will get du over secant squared x. All right, so now we're going to plug it in, okay? So we're going to go integral of, don't write 0 to pi over 3 right now, okay? Because I'm going to tell you why in just a minute. But we're going to do u times secant squared x, and dx is du over secant squared x. So that's pretty great. And then, of course, those will reduce, leaving you with the integral of u du. Now, here's the thing. What happened to 0 to pi over 3? Well, when we're integrating for u, it's not going to be 0 to pi over 3 anymore. That was for x. So we need to find out what the interval is. So the interval for x was 0 to pi over 3. But what's the interval for u? Okay? So this is what we're going to do. We're going to find out what these numbers are in terms of u. Okay? So u equals tangent of x. We wrote that down way back here. U equals tangent x. And so what we're going to do is we're going to do u equals, since x is 0 to pi over 3, then this would be tangent of 0. We have to find out what that is. Okay? That's going to give us our a term. And then u will equal tangent of pi over 3. That'll give us the b term. Maybe I should write like a equals and b equals instead of u for our interval. So what is the tangent of 0? Do you know what the tangent of 0 is? You can use your calculator if you need to. 0 over 1. So 0. And if you need to, plug in tangent 0. Your calculator will tell you 0 also. All right, this one though, tangent of pi over 3. Tangent of pi over 3 is if I went to here and I make sure that I'm in radian mode and I did tangent of pi over 3, it's not going to give me a nice number. What is that number? That number is the square root of 3. Do you know them? No?
Remember, like every time from
Yeah.
the cheat?
Yes.
Like if it was pi over 3, you rad 3.
Yes. So this is rad 3. And so this is going to go here from 0 to rad 3 instead. Okay, so now we need to evaluate this. 0 to rad 3 of u du. So here we go. You guys remember how to do this? We're going to find the antiderivative of u. So then that would be u squared over 2. You don't need plus c here because it's a definite integral. It's just going to cancel it out if you had plus c. You're going from 0 to rad 3. Now, here's the thing. If you wrote 1.7 something, it's not going to be right. It's not going to be exactly right if you rounded. Because now let's plug these in, and we get rad 3 squared over 2 minus 0 squared over 2. And so the answer is 3/2. There you go.
So you never have to put the tangent in
You never have to put it back in. See, instead of doing that, I mean, you could have done it that way. You could have gone back and evaluated it with tangent. It would have worked the same, but this is to evaluate it in terms of u. You have to change the interval to terms of u. It's really either way. You're going to have to do it either way. All right, let's do one more. One more, number 2.
That's it?
Yeah. I hope
And
Sophia's
isn't that
watching
whole
this.
quiz on?
The whole quiz on Friday
Yeah. This
is on
too?
U-Substitution.
Good idea?
Yep. Yeah. Yeah. Hopefully it'll raise some people's grades. I don't know. I look at that side of the room over there by the sun. Okay, here we go. And we're going to evaluate. Evaluate from 0 to 1 for x over x squared minus 4. And they tell you to let u equal x squared minus 4. All right. So let's do it. Here we go. So we want to integrate from 0 to 1. And you can leave that 0 to 1 off if you want to. Or you can just write it. It doesn't matter. We're going to have to change it later. So this is going to be x over u. Oops, I forgot dx, didn't I? Dx. Does that bother anybody else? No. Okay. Over here, let's take the derivative of u. So we get du dx equals 2x. Good? Okay. And so then that means that dx is equal to du over 2x. This should be very familiar, especially if you did the homework last night, then you know pretty much how to do this stuff. Okay, so now we're going to integrate 0 to 1 of x over u. And instead of dx, we're going to substitute du over 2x in. Du over 2x, okay? And so then this would equal the integral. I'm going to leave the 0 and the 1 off for now because my x's are reduced, and so there's no longer any x's in here. And I'm also going to bring that 2 out front, or the 1/2. 1/2 out front. And then this is 1 over u du. And let's find out what my a to b is. So for x, a to b is the interval from 0 to 1. That's for x. But for u, a to b will be, go up here to where u is. When x is 0, what's u? -4. And then when x is 1, -3.
And then that's on A and B.
Yeah. So then we can write -4 to -3. Okay, here we go. Let's now go ahead and take the antiderivative. So we have 1/2. The antiderivative of 1 over u is tricky. Because if you tried to think of this as u to the -1, yes!
You also know that.
You were? If you take this as u to the -1, you add 1 to it, you get u to the 0. That's not going to help you. This is a special one. This is the absolute value. No, take that back. It is the natural log of the absolute value of u. That's what it always has been. We just didn't.
U or just
Oh,
X?
don't write plus c. No, we don't need that. Whenever it's, yeah, if you take the derivative of 1 over x, it's like, so if you have y equals 1 over x and you find dy dx, we always just write natural log of x, right? No. No, I did it wrong. No. No, if you have y equals the natural log of x and we find the derivative, we find y prime. We always say that's equal to 1 over x. What we're doing is we're finding the natural log of x. X has to be positive. It has to be. Can you take the natural log of a negative number? No, you can't. Okay? So then we have to make sure that we write it as the natural log of positive u. So when we evaluate this, we're going to evaluate this -4 to -3. We're actually going to plug in +3 and +4. Okay? All right, so here we go. Let's evaluate this. We get 1/2 natural log of 3 minus 1/2 natural log of 4. Now they might ask you to leave it in terms of natural log. Do you know how to do that? Do you remember your log properties?
Well, that's division, right?
Yes! So then this would be, if you were to take 1/2 and bring it out front, it's the natural log of 3 minus the natural log of 4. And if we write that all as one natural log, it would be the natural log of 3/4. And that would be fine for me. They might take that 1/2. No, you don't need plus c on the definite ones. They might take that 1/2 and put it up as a power. Remember that? Natural log of 3/4 to the 1/2, which is the natural log of the square root of 3 over 2. You square root the 3 to the 1/2, square root the 4 is +2.
Can we leave it at 1/2?
Yeah, right here. But see, this might be a multiple choice question, and then you won't see your choice, and you'll be like, well, which one is it? So you,
That says it's a multiple choice.
oh, that would be such a good one.
I do.